Hello, and welcome to today's lesson on linear regression. So, today's learning goal. You can use technology to obtain an algebraic model for a set of data using the concept of linear regression. So, I cheated a little bit because I showed you how to use the calculator yesterday, and the calculator does everything for you, right? So, this is more practice on A, using the calculator, and B, it's that critical analysis part that's very, very important. So, a couple of terms you need to be familiar with. Term regression comes up throughout this unit, and regression is an analytic technique for determining the relationship between a dependent and an independent variable. So it's a process in which we come up with a mathematical model, an equation between an x and a y variable. And that's exactly what you're doing when you're looking for relationships in the data that you get from your project. Way back to grade 9, interpolation. This is when you use given data to approximate an answer within the graph given. So we did that in the grade 9 course where I gave you a temperature and you had to find the corresponding Fahrenheit, Celsius. So you're just using a graph to find another piece of information. Extrapolation is one of the things we're going to be using in this particular topic today. And that's when we take our data, we get the model using the calculator, so we get our equation, and then now we predict the future, predict possibilities or outcomes based on that information that's outside the data you've already collected. So regression. What is regression? It uses what we call a least squares method to estimate the equation for the given data. So what happens if you have a scatter plot, and I'm just going to throw a couple of points on here. You don't need too many. And we do a line of best fit, which that's not really that close. I'm trying to do a little bit better job here. So line of best fit. So what regression does is it creates a box, as best I can draw here, okay, or boxes that connects a corner of the box, or squares, of the data point to the line of best fit. And it uses this process then, uses this process of drawing a square that connects to it in order to come up with that slope equation. And that's where the term least squares come from. So the equation itself, and I did it on this slide as well. So again, just talking about that. Okay, least squares method. Each of these dots will be connected to our line of best fit. And all you're doing is it's an approximation of our slope and y-intercept and so on and so forth. So the formula you've got right there for the line of best fit, and I talked about this in the previous video, y equals mx plus b. You need to know that equation. And the a value, okay, our textbook uses a, the calculator uses a. I wish people would get their act together and come to an agreement and just use m, because that's what students are more familiar with. But remember, a is just slope, as it was in grade 9 and 10. This is how you calculate slope, okay, underneath m, or slope. So here's the equation. And again, before people start, needing a paper bag to breathe into, we've got a calculator, we have software that does this. So I'm not going to force you to go through the process of using this to come up with the answer. I'm just making you aware this is the equation. You can technically go through and you can do it by longhand. We talked about n is the number of data pieces that are collected. X is your individual data points that are involved, and then your x bar, well, in this case there's no mean that's used here, so we're basically using the x and y value multiplied together, the sum of all of them, and so on and so forth. So you could do this by hand. Having you do it, though, is a severe waste of your time, since we have software and programs to do it. All right. So that being said, that's what your calculator is doing for you. Okay. This is the formula that it's using to get there. It doesn't have to go on your formula sheet because you will not be using it. Okay. So straight into some examples then. So very, very similar to yesterday. Like I said, I cheated a little bit because I did a little bit extra yesterday that wasn't probably necessary to answer the questions. However, it's all done really at once with the calculator. So the table shows for full-time employees of a small company, or shows the data. So we've got age in the one column, and we have annual income in the other. And we want to create a scatter plot of the data. So every day you get to the calculator, it's best that you reset it because you don't know what the person was doing the day before. So one more time, second plus 712. That resets the memory. Second 0, which takes you to catalog. You got to scroll all the way down to D because we need to put the diagnostic mode on. All the way down here, we're getting close. There it is, diagnostic mode on. Hit enter. Second, y equals, enter. I want the scatter plot mode on so I can actually do some scatter plots, and now I'm all set. So I can hit stat, and I'm going to edit. I'm going to enter this information in. So again, L1 is your X values, L2 is your Y. So quickly running down the list here, 25. Oops, I don't know why I put plus. Doesn't make any sense. 19, 44, and 50, 54, 38. And go up and put my Y values in. So 33, 31, 18, 56, 60, 64, 44. All right. Remember, you got to do a window. So I'm going to hit the window, and this is where you're choosing the size. So from -10 to 10 for X values is no good. So I'm looking at my X column, and am I going to have a 0-year-old in age work at the company? Probably not. You can leave it as 0 though, or you can move it up. It doesn't matter. But you know that you're not going to have anyone younger than 0 at the company. As far as the max age goes, 54 is up there, so let's go 65 is usually roughly retirement age. 0 pay all the way up to, it looks like 64, so I'll pick 70, as long as you're larger than the biggest piece of data given. And hey, lo and behold, look at the graph there, or the scatter plot. So right away I'm thinking, hey, this looks like a linear model because the data points seem to line up. So A part, create a scatter plot of the data. No problem, all done. So to make my life easier, I'm just gonna capture that. And again, when you're doing it with the software, you're gonna just be writing down information for me, what's on the screen. I'll probably give you some screenshots and stuff to fill in the blanks. So anyway, I'm just doing that so it's easier to see in terms of what it looks like in front of you, and I can draw and comment on it. B part, determine the degree of correlation. So it's exactly what you did yesterday. So going back to the calculator, I want to determine the degree of correlation. I know it's linear looking at it. So I'm going to go to calc. Sorry, I hit stat first, moved across to calc, and you want to go down to linear regression. I'm going to hit enter, enter again, and here's all my information that I need today. So you can copy this down, and I'm going to cheat and do a screenshot since it's just easier for the note purpose here. And of course it's on the wrong page. No sense being helpful. There we go. So there's my part of my B part. Actually, why don't I set it up like this? I'm going to scroll down a little bit here. There's that. So over here, B part. Determine the degree of correlation. R equals 0.98. Determine the equation. Well, a lot harder in the old days before calculators. Back in my day, rode the dinosaurs to work. Again, y equals mx plus b. It tells you A goes there, B goes there, so it's not a stretch. Now, what I want you to do for me in this course is you need to be able to tell me what the variables are. Okay, very, very important. So you're going to have to give me a legend or let statements where y represents the income, annual income. So this is a must for communication. All right. I'm going to probably, on a test, I'm going to give you this here, but I'll leave the numbers blank so you can fill in the information that appears on the screen. That way I can determine whether you just didn't enter something in right. And X is going to represent the age. All right, so you have to, this is an absolute must. Okay, so please make sure you make a note of that, that I need to see that in your solutions. So there's A, B, and C done. D part, use your model to predict the income for an employee of age 21. So you can go to the graph. Now, it's a little trickier with us because we're not doing the graph, and it's not a regular graph, so to speak. So we can't just read off our graph because the XY axes on the calculator don't show. So for the D part, we're just going to use our equation. All right, so D part, first one was 21 years, and you need to make sure you know what variable that is. And if we go back here, X is the age, so that's our X value. So to answer the first one, Y equals 1.3 multiplied by 21 and minus the 5.7. So you plug that into the calculator, and you will get 21.6. So therefore, they would make 21.6 thousand. That's in dollars. And the second part there, what was it? 21 and 65. So someone who's near retirement age. So it's just plugging in, and again, recognizing that age is your X value. So 1.3 times 65 minus the 5.7. And in this case, you get 78.8. Oops. 78.8. So therefore, a 65-year-old would make 78.8 thousand. Now, the one thing I don't like about the homework, and I don't like about this question, the questions I do here model the questions from the homework, so you have an idea what to expect. C part, B part, and C part, I like you to talk about how good is this model. So up here we see that the correlation coefficient here is 0.98. So just as something that you should keep in the back of your mind, when R equals 0.98, the model is really strong. And it's this because. Okay, so it's really strong. Why is that? Okay, so these are factors beyond the question, but I want you to be able to do this again. It's for this project. It's extending it. So why does this make sense? Well, more experience is worth more. If you know your job really, really well, and you do a great job with it, you should be rewarded. And most companies will reward that experience. Hey, it may be a automatic. So if you put so many hours in or so many years in, you get automatic increases. Okay, so I'm looking for that critical analysis. Do you understand? Does this make sense? And if it's really strong, why is it really strong? So this is the type of question that I would add to the homework questions you're looking at. It's that explanation as to the why. So keep that in mind when you're going through. Make sure, don't be afraid to talk with the partner over that. And making sure you understand the why. So got two more examples, one more with this, and then there's one that we want to look at in terms of outliers and how to change things. So we'll see you later.